Welcome to chemistry classes. Today's class is again on chemical kinetics and it is lecture number 24 in continuation of class number 23. It is a chapter in higher secondary second year and it is subtopic is integrated rate law and pseudo first order reaction. So before starting the classes, let me give a bit tips or some important points which to be noted at the very beginning. So at the very beginning, before starting the classes, let me tell some of the important facts about the topic, and it is a very important topic because each and every year a question is asked from entrance exams. Also, it is important for your class exam for NCERT and state level. Both did the same. This topic is very important. So first of all, I will derive each and every one. First of all, zero order reaction, the K is the rate constant. K is equal to A naught by A by T, where A naught is the initial concentration and A is the concentration after time T and T is the time. And for first order reaction, that is equal to K equal to 2.303 by T log A naught by A is the initial concentration, A is the concentration after time T, or that may be written as K equal to 3.303 by log A by A minus X. I will explain bit by bit. Again, T half for zero order reaction equal to A naught divided by 2K. A naught is same as earlier I have mentioned. T half of the first order reaction equal to 0.693 by T, and zero order and zero order reaction in y equal to mx plus from very often question asks. That's why I have written is that has been written from here. If you cross multiply, you will get kt equal to A naught by A. From this, I have arranged this minus A naught is the concentration after time t, and I have arranged it in minus kt plus y is equal to mx plus c form, so that m is the slope and slope is the here minus k, and A is the concentration after time t, that is y, and A naught is the concentration at the initial time, and that is constant, that is c. Y is equal to mx plus c. I will explain it a bit later with a graph. N is equal to n naught half of n. It is another formula where n is n and n naught is the fraction. If you take it one below the other, n by n naught is equal to half of n. N by n naught equal to half of n, where n is the n by n naught is a fraction and half is a formula. N is equal to total number divided by t half. And another very important thing, sometimes you are supplied the value of log, but you must learn it by heart. Log 2 equal to 0.3010 and log 3 is equal to 0.4771 and log 6 is equal to 0.6021. You should learn these three at least so that you can solve each and every one from yourself without taking any help, whether it is supplied to your with your exam questions or not. You need not look at this. So this is the some of the important things you should learn. Zero order reaction. Say A gives B. That is rate. That is rate. Rate is equal to minus d by dt, and that rate is equal to some constant and rate expression is the concentration of A, and since it is zero order, its order is zero. Am I right? So now minus d A by dt is equal to A to the power 0 is equal to 1. That is K is equal to, if you write in right side, so we will write that is change of concentration and that change of concentration is final minus initial concentration. Say at time t is equal to 0, the initial concentration was A naught. After time t, the initial concentration changes to A. So change of concentration is equal to final minus initial concentration A minus A naught divided by T. And if you change the multiply this sign, so we will get A naught by A. This is very important one. Very often it will come in it. So for zero water reaction, K is equal to A naught concentration A naught minus concentration A by T. It is very important. So we have got K is equal to A naught A by T for zero order reaction. It is important. In mathematics, we will come across. So now first order reaction. Say A gives product here minus that is equal to rate. You can write rate. Rate is equal to this, and this is equal to rate expression concentration A. Since it is first order reaction, that will be 1. So if you arrange it, we will add, if you take this one here and dt here, so dA by dt is equal to kt. On integration, what we get? This is concentration, sorry, constant for integration. So from 1, we can write, if you put, if at time t is equal to 0, then ln A is equal to minus k into 0 plus c, and at 0 concentration, at time t, the concentration A should be A naught, initial concentration. That's why at time t is equal to 0, that ln A should be ln A naught, and k t is equal to 0, that we are getting C is equal to ln A naught. Now putting this value here, we get am I right? So C is equal to ln A naught. We are putting this value here. So ln A is equal to minus kt plus C is equal to ln A naught. We are taking both the ln part in one side and kt towards right. So ln A minus B is equal to ln A by B. ln A by B So at the very beginning, I wrote is equal to k is equal to 2.303 by t log A naught by A. Sorry, there is some wrong with the sign convention. Um, let us make it positive. This is negative, is not it? Multiply all through minus with minus. So ln a naught minus ln a is equal to kt, or ln a naught by a is equal to kt. Ln changes to 2.303 into log 2.303 log a naught by a kt, or 2.303 log, below it we are taking t, a naught by a is equal to k. This is the expression. Sometimes in the state exam or NCERT exam, the integrated fast order reaction is asked to derive. So you will derive in this way I have shown you. So k is equal to 2.303 log t by a naught by a. So this is all about the derivation. Now we can also write it in the form k equal to 2.303 t log a by a minus x, where a is the initial concentration and a minus x is equal to some amount of the reactant has already been used to give the product. So remaining left out product concentration is a minus x. X is the amount which has already been reacted to form the product, and if you get the left out product of concentration, you will get a minus x, a minus x. So a minus x, that can be written in this way because this form is also used in doing the problem. That's why I have shown you. So now we have written k is equal to 2.303 . This is the rate constant for first order reaction. Now let us define T half. T half is the concentration which reduced to half after a time. So in short, I have written that T half of the first order reactions here T half. I am taking the time in which the concentration of the reactant reduced to half of its initial concentration. What is the concentration of initially it was? After some time, that concentration becomes half, and that time in which the initial concentration reduced to half is called the half-life period. So T half, we will now explain how to convert T half, how we will find T half. So at T half, so you will write k is equal to 2.303, and if T is the T half in reduced to half after some time, so log a naught is a naught, and this concentration is reduced to half. So you will get, and we have already very beginning I wrote to the value of log 2 is equal to 0.3010. You should learn it by heart, and this two, if you multiply these two, you will get 0.693 T half, and this is the expression of T half between T half and rate constant k of the first order reaction. So k is equal to 0.693 T half. So I have derived. And why I have derived it? Because of the fact that sometimes in the questions it is asked that so that first order half-life period of first order reaction is independent of concentration. There is no concentration term in K. So now for zero order, without the expression was like this. At the very beginning I wrote, and I have shown you also how it is like that. K is equal to a naught minus a by t. So what is a T half for zero order reaction, that's in that time we have, so that becomes half of the initial concentration. Am I right? So here you are getting a naught, and there is 2 below, is not it? So we can write it in this way, uh, or we can write T half for zero order reaction is equal to concentration a naught into 2f. It is again important, that's why I have written, I wrote it earlier here. So I have applied this. T half for first order reaction equal to 0.693 by 2, and T half for zero order reaction is equal to a naught by twice k, and I have shown you how it is. This is pseudo first order reaction. It is not true first order reactions, but show first order kinetics under certain condition. That is, acid hydrolysis of ester is an example fast pseudo first order reaction. Means it um, in presence of, that's why let me show an example. Say it is an ester, when in presence of acid we make it acid and alcohol, and here say here two molecules, here two molecules means ester, and water in presence of acid is used, but here water is in excess, use of water is in excess. So the change of concentration or amount of water in comparison to this is negligible. And this is the condition, this is the condition in which the reaction seems is the reaction shows pseudo character. It is not true first order reaction, but show first order kinetics under certain condition. Two molecules are taking part, but it is first order reaction because of the fact that water is used in excess. In comparison, the change of concentration or amount of water to give the product is negligible in comparison to this. That's why its change of concentration is not appreciable, not noticeable. Hence, though there is water, yet it is depend only upon the concentration of this one. Hence, it is called pseudo first order reaction. Practical application of this chapter. In this chapter is full of mathematics and a lots of theories there, and very often in entrance exam, a lots of question appears AIEEE, NEET, and other competitive JEE in exams. Questions are asked. The first question is, the rate constant I am telling the question. Question is, for first order reaction, T half for a first order reaction is assumed to be X, and time period for T fourth of the same reaction is assumed to be 1. This is time period. Time period for same reaction of T fourth time period is assumed to be Y, and you are asked to establish relation between X and Y. T half for the first order reaction is assumed to be X, and time period for T fourth time period of the same reaction is found to be Y. What is the relation between this and that? So it is first order reaction, am I right? So you write K is equal to T half, and you are given this is X, so we have got K is equal to, am I right? So again K is equal to or you can write it here A by A minus X. Here A is A. What is X? X is this much, means 3/4 of initial has, that is X. A is X, initial concentration, and 3/4 of the initial concentration is left out. That is A minus X is equal to A minus 3/4A is equal to A by 4. Am I right? A is the initial concentration and X is 3/4 of initial. 3/4 of initial. So A minus X is equal to A minus 3/4 of A is equal to A by 4. So what you get? A by A minus X is equal to and that is T 3/4. Am I right? It is T half equal to X. T 3/4 is equal to, as per our condition, it is Y. It is supplied. So here log A is A and here is A by 4. So what we get here is log 4. So now comparing 1 and 2, 1 and 2, what you get, that K are equal, that 0.693 divided by X equal to 2.303 Y log 4. Am I right? So here you see 2.303 into, it is 2 log 2. It is 2 square. Log 4 is 2 square. So this is 2 log 2 and log 2 is equal to 3010. At the very beginning I told you 2.303 and 0.301310 gives you 0.693. So you are getting 2 into that 2 value is equal to 693 divided by Y. That K is equal to, sorry, that 2 into 0.693 divided by Y. So what we get here is, from this we started, this equal to this, and from that part we go on doing in this way. We got last result is this. So finally we got 693x is equal to the last one, 2 into 693y. So you cancel out. So we get y is equal to twice x. Have you followed this? Very simple. K is equal to this t half. This is very simple one. And for the second, it is 3/4, 5/5, 6, 7. If you are there is in fraction more than half, then we need to apply this formula. K is equal to 2.30 t half log A by A minus x. Where is 3/4 means x is equal to 3/4 of A. So A minus x, we are getting this is equal to log 4. We got K is equal to 2.303, Y is equal to log 4. Am I right? Now we compared 1 and 2. So K cancels out. We got 6.303 divided by x is equal to 2.303 log 4 by y. And log 4 is equal to 2 log 2. It is 2 square. 2 square here, it comes as coefficient 2 log 2. Log 2 equal to 0.36. So 0.36 and this is 0.693. Am I right? So we are getting 2 into 0.693. So this part and this part's equating, this into this cancels out. So we get 1 by x is equal to 2 by y. That gives you y is equal to twice x. Beauty. R is equal to P and the graph is given in this way, and you are asked find the order of the reaction, and it is its slopes. So it starts from that is equal to R naught initial concentration. Am I right? So initial concentration R naught that is R naught. Am I right? Initial concentration it touched here, it is 0 initial concentration, and it is coming in this way, it is in linear, it is a zero order reaction. First of all, one, it is zero order reaction. And what is slope? That's why I wrote the zero order reaction in the form of this at the very beginning. You keep it in your mind. I wrote the y is equal to mx plus c form. So y is equal to mx plus c form, that is in concentration after time t is equal to a naught. Concentration initial concentration was a naught, and minus kt. I multiplied at the very beginning. I told you cross multiply the, you will get this result at the very beginning. So is equal to y is equal to mx plus y is equal to mx plus c is not it. So this is m. Therefore m means slope. Therefore slope is equal to minus k. This is the answer. Very simple. You just strike the point, you will get the marks. This is very simple. Again, hydrogen peroxide decomposing into water and oxygen is found to be first order reactions where the reaction constant k equal to 1.06 10 to the minus 3 per minute, and you are asked to find the time for which there will be 15% decomposition of hydrogen peroxide and time for which 80% decomposition of water. What will be the time for 15% decomposition of water, and what will be the time required for 80% decomposition of hydrogen peroxide into water and oxygen? So how will you do? It is first order reaction. It is first order reaction. So you will write k is equal to 2.303 divided by t log a by, better when there is a percentage, when there is percentage you write a by a minus x form. So for first reaction we'll write k is equal to, the value of k is equal to so t is equal to, you write 2.30 t divided by k log, what is a is the concentration. When it is 50%, a is equal to 100, am I right? And 15% means if a is equal to 100, a minus x is equal to 100 minus this 15, so you are getting 85. So a minus s is equal to 85. So here t is equal to 2.303 and the value of k is equal to so if you find out the value of 1.77, that is 0.0704, am I right? Now we have to solve out this one, and this is tricky one. You very often cannot find in correct way. Now I am showing you. You assume only these two. So what you get here is 2.3, and you assume here these two 0.7. No need to assume any decimal, it is known to you. This is 1.61, 1.06 into 10 to the power 3, and if you divide, just you divide, you will find the value 122 minutes. So first one is over. Now for 2, t is equal to 2.30 t by k log a by a minus x, and to you are to get 80%. Am I right? So 2.303, it is 100. 100 minus 80, 100 minus 80, you are getting 20. You take the value of log 5 and you do the solution. You will get, I think it is 127 minutes. 177 minutes. Next question you were given, it is a first order reaction. In the first order reaction, it is seen that after 40 minutes, the 30% decomposition of the reactant occurs. And you are asked to find out T half, and given log 1.428 is equal to 0.1528. So since it is a first order 3 equal to T log A by A minus X. So that is equal to 2.303, and the time is equal to 40. Am I right? And here log A is equal to 100, and A minus X means 30%, A minus 30 means 70. So you are getting 2.40 into log 10 by 7, and that is equal to 2.303 divided by 40, and log 1.428 is equal to 1548. 1548. So 2.303 into 1548. Am I right? Divided by 40. So just you take these two 23 and you take these two 1.5. Am I right? Let's see. So your result is 345. The above result is this. We are taking this and this only. We will not assume other things. So here below you are getting 40. So you have to divide it by 40. So when you will divide it by 40, that is you need not assume point 3, 4, 5, 40. So you see, we have done this one and we got the result. Each and everyone can get this result 0.345, and when we have divided it, we have not assumed point. We just divided 40 by 345. We got the answer 8.63. We get the you don't assume this point. We got the answer 8.63. Am I right? Now you see, after decimal there is 3 unit and there is no decimal. No decimal means 0, you are getting plus 3 result. I have earlier told you, if the decimal result is plus, you move the decimal towards left. So plus 3 means towards 3 unit left. 1 2 3. So your answer will be 11163 here decimal. So if you cannot put the decimal correctly, so that point, that the value of k again dependent upon the t half. Am I right? So you do in this way. When you divide this one, you don't assume any decimal. If there is decimal at the final result, above decimal minus below decimal, and what the result? If it is plus, make the decimal move towards left. If it is minus, make that amount of minus towards right. So if it is plus, so move the decimal towards 3 unit left. So you are getting 0.00863. Now you put the value. You are asked to find out t half. T half is equal to 0.693 divided by k equal to 0.693 divided by k. K is 0.00863. Am I right? Again you will find difficult to find out the result. So you take only 69, you take only 69 means 70. You can take 70, no harm, don't assume any decimal. Am I right? You take this one, and here you take only these two, 86. Am I right? You will get 6. In this way you will get the result. You will get the result, this divided by this, you will get the result 776, nearly point, because there was 70, I put point to give 0 point. This now you come to decimal. So here in above there is, I have taken 2 here only, no, 2, you assume 2 after decimal 2 units, and I have taken 86, 1 2 3 4 units. 2 4 means minus 2. Minus 2 means you have to move decimal towards right. Your answer will be 77.6. So this is the trick I have shown you, because besides this you can't find out the original answer. If you want to find the original answer, you will lose a lot of time. So you just take 2 unit and take 2 unit number. So in 2 unit, when you divide 70 divided by 86, you will get the answer. Everybody of you know 776.776. Now you have taken 2 units, so after decimal there is 2 means 2, and after decimal 86 you have assumed 1 2 3 4. You are getting 4. 2 minus 4 equal to minus 4. When there is minus 4, move decimal towards right 2 units. So 1 2. This is the answer. This is the trick. Mind that it will come a lot in solving the accurate problem, getting the answer inaccurate. Mind that this is very important problem. The transformation of the reaction, where the some reactant are transforming or decomposing, the T half of the reactants is found to be 10 minutes, and you are asked to find K for the first order reaction and fraction left after 1 hour. So K is equal to this is very simple. You can find out. Now fraction left after 1 hour. First one is very simple. Now for second one, what you need, I wrote a question at the very beginning. I gave a formula. N by n naught is a fraction. The amount after time t and initial amount, it is a fraction that is equal to half of n. What is n? I told you n is equal to total time n divided by t half. So here in this question, your t half is the 10 and total time is you are giving 1 hour. 1 hour means 60 minutes and t half is equal to 10. So you are getting 6. So n is equal to 6. So n by n naught is equal to half into 6. I think it is 1 by 64. So amount left after 1 hour is 1 by 64. Am I right? Is it not excellent? Again, if you are confused, if you can't understand, say from one reactant, one amount one for first t half, you are getting half. For second t half, you are getting 1/4. For third t half, you are getting 1/8. For this, you are getting this. You are getting this. For next t half, you are getting 164. You see how many t half you got. This is 10 hours. 10 hours. Mind that from 1 unit to half means half-life period, it is 10 hours. From first t half, it is half. Again for another t half, this half. So how many t halves you have got? You need to get 1 hour means 60 minutes. 10 minutes, 10 minutes, 10 minutes, 10 minutes, 10, 10, 10, you are getting 610. So after 610, 6 half-life time, you are getting 164. Your answer you can do in this way. You can do in this way. So it is a bit lengthy. It is shortcut. For first order reaction, the concentration of reactant changes from this to this in 5 minutes. Find K. It is very simple. This is initial concentration A naught is equal to 0.06 mole per liter, and this is final concentration after time t is equal to 0.2 mole per liter. Am I right? This is 2. And what is the time after time? After time 5 minutes. The time is 5 minutes. So you are asked to k equal to 2.303 into t of log a naught by a. So you go on solving this one, you yourself can find out. This is not tough one. I am not doing the sum. So 2.303 divided by 5, and this is log 3, and log 3 is equal to 0.4771. It is learned to you all. The question, I am not writing the complete answer question. So the question for first order reaction, it is found that in 20 minutes the reaction completed 25%. What will be the time to complete the reaction? For the reaction to complete 75%. Complete 75%. Am I right? In 20 minutes the reaction completed 25%. What will be the time to complete the reaction 75%? So from this we'll write K is equal to 25% means if it is 100, this is 75. Now come to this point. We don't know what is time, but reaction to be completed 75%. So here K is equal to If it is 100, then it is 25. So if you compare these two, where we'll get so this two will come out if you calculate. So we'll get 1 by 20, and this is equal to log 4 minus log 3. It is known to you all, and this is log 4. The value of log 4 is equal to 6021 divided by t. Am I right? So 1 by 20 log 4 is equal to 6021, and log 3 is equal to 0.771. You solve out simply to find out t. Am I right? I am not saying because it takes time. I am not writing the exact question. What I recall, I am just writing. So for first order reaction, time taken for 90% of the reaction is twice the time taken for completion of 90%. Now what is 99%? T is equal to, right, in the form of K is equal to so if it is 99%, then A is equal to 100, and M minus X equal to 100 minus 99 means 1. Am I right? So you are getting 1, and here for the second to 90%, am I right? 2.303 divided by T of 90%. How much? 90. Am I right? If it is 100, then 100 minus 90 is A minus X, that is 10. You are here getting 10. So if you compare these two, you are getting 2.303 divided by T of 99% log 10 square, 2.303 T of 90% log 10. So this is equal to 2. 2 coefficient comes here. Am I right? So 2 into 2.303 divided by T of 99%, and log 10 is equal to 1. We need not to write 2.303 T of 90%, and log 10 is equal to again 1. So if you compare these two, we'll get T of 99% is equal to twice of T of 90%. Question was asked in ZEE Odisha. So half-life of two sample is 0.1 and 0.4 second, and concentration of these two sample is 200 and 550 respectively. Find the order. We know T half is proportional to concentration to the power n minus 1. So T half of this 0.1 divided by T half of this, you are getting two concentration. For one concentration 0.1, second concentration 0.4, and this is equal to A to the power. Concentration is first one is 200 and second one is 50 is the initial concentration to the power n minus 1. From this relation we are taking two sets and dividing one set by another. For first set is concentration of this sample half-life period is 1 for this concentration, and half-life period is 4 seconds for this second. Am I right? So here you are getting 1 by 4 is equal to, this is 4 by 1 and this is equal to n minus 1. Am I right? So here you are getting 1 by 4 is equal to, if you reverse it, so make it 1 minus n. So t half is proportional to a to the power 1 minus n. This is the formula. So from here we get 1 by 4 is equal to 4 by 1. This is 1 by n. So 1 by 4, if you make it 1 by 4, so you change the power as this. Am I right? So 1 by 4 to the power 1. So 1 by 4 to the power n minus 1. Comparing these two, we get n minus 1 is equal to 1, n is equal to 2. So it is second order reaction. One is always 1, and it is again came in ZEE. This came in neat. So 50% 2 hours and 75% completion of the reaction occurs in 4 hours. Find the order. Very simple. Again you see K is equal to 2.303 divided by T log A by A minus X. So for 50% K is equal to 2.303 and it is T of 50%. You write T of 50% and log 100. If it is 50%, so F is 100, A minus 50 is equal to 50. Again for 75%, K equal to 2.303. Am I right? T of 75% is equal to log. If A is equal to 100, so A minus X is equal to 100 minus 75 means 25. Now comparing this K, we get 2.303 divided by T50 log 2 is equal to 2.303 T of 75 log 4. Am I right? So you see, this is log 2 divided by T of 50% and here 2 log 2. It is 2 square. Am I right? So 2 comes as coefficient. So you are getting 2 log 2 T of 75%. So you see, from this, if you cancels out, you will get T 75% is equal to 2 into T 5%. What is the relation between T 75 and T 50? 2 hours 50% and 4 hours 75%. Establish the relation of these two reactions. Answer: T75 is equal to twice of 250. This is the relation of time between 75% and 50% of the reaction. This is the end of the tutorial class, and in the next class will be the last and finishing class. Please subscribe the class to make another avail the opportunity of watching the videos. Thanks a lot for watching.